Welcome to my 6-part tutorial series to teach you how to make a platformer in GameMaker. I am Dr. Skylar Earl Anderson at the University of St. Thomas, and where we left off from our last video is we had a checkpoint system, we had hazards, we had wall jumping, we even added a little weapon system, and a little explosion animation for those enemies when you hit them. In this video, we're going to be covering room transitions like fade ins, fade outs, moving to different rooms or different levels. We're going to be adding a game camera that will be able to follow our character in much bigger rooms. And we're going to add a little camera screen shake effect that we can add to sprinkle in wherever we like. So let's get started. First, I want to apologize. I just got back from lunch, so if I'm like gross or burpy or something, it's just that I ran off to lunch and I came back to record this tutorial. So first, fade ins, fade outs. We're going to build a system with some scripts and a fading object that will black out the screen when we need it to be blacked out to fade out, and also fade in from a black screen when we need to fade in. So let's start by creating that object. Create object. It is called oFade. And in the create event, let's declare a bunch of variables that we need. Those variables are fade underscore out, which is a Boolean set to false, defaults to fading in. So this fade object is going to be used for both fade ins and fade outs, but we're going to create it so by default it just fades in. So if the object gets created, it does a fade in, but then we can change this variable using a script later to cause it to fade out. A equals 1, which is the alpha value or the transparency value. Target underscore room equals this room for now, and it's a temporary room, will be changed. Fade out rate equals 0.05, semicolon, how fast to fade out. Fade in rate equals 0.05, semicolon, how fast to fade in. W equals display get GUI width, which is the width of the game screen, and H equals display get GUI height. Comments, height of the game screen. Now, if your game is only ever just your room, then we don't have to do something like this. We can just use room width, room height. But since we're going to be building rooms that are much bigger than our actual camera or the screen that it's going to be showing us, we should just only create fade in on the screen that we're looking at, not the entire room. Add a step event, step, and let's set in the fade in and fade out. If fade out is true, if fade out, let's add a comment here. Fade out from clear to black. And then else, and this means fade in from black to clear. So when fade out is true, we want the code to do this, and when fade out is false, we want it to do this. So let's start with fading out. If A is less than 1. Open, close curly bracket. If not, completely black. A plus equals fade out rate. Make more black. We're going to add an else here for when A equals 1. If A is no longer less than 1, let's set it to be equal exactly 1. Set to 100% black. Room, go to target underscore room. So for fading out, it'll start transparent, so A will start at 0, and as long as it's less than 1 or 100%, it'll gradually increase in how visible it is, and then when it gets to 1, we'll lock it in at 1 and go to the room we need to go to. Slightly different, but similar code for fading in. If A is greater than 0, open and close curly bracket. Now let's also add the else right away. So if not completely clear, A minus equals fade in rate, make more clear or transparent, else, excuse me, that's embarrassing. Anyway, let's go. A equals 0, set to 0% black, instance destroy. So once it's all the way faded in and we can no longer see any traces of the screen being black anymore, we just destroy the fade object. And lastly, let's add a draw GUI event. The draw GUI event, unlike a draw event, the draw GUI event will draw everything in relationship to the screen the player is seeing. So if you put in like a horizontal location value of 100, it will not be 100 pixels from the left of the room or in the room. It'll be 100 pixels from the left of the game screen. So this is great to just only cover what the game screen is. So for that, let's set up our colors and our values here. Draw set color, do black. We could also do purple since our background color is going to be purple. So that'd be kind of like on brand for this game. In fact, you know what? If it looks bad, I'll change it back from purple, but for now I'll just set it to purple instead of black, but you can set it to black. Draw set alpha A, draw rectangle, 0, 0, meaning the top left corner of the game screen, W and H for the bottom right-hand corner of the game screen, and false for whether we want it to be an outline. No, we want it filled in, so we set it to false. Draw set alpha back to 1. All right, so now we need to write the script to call this fade object into existence and to use it. So let's create a new script. Call this fade, how do I call it? Fade in, just fade in. And then write if bang instance exists. So if the instance does not exist, fade, double close parentheses, instance create layer 0, 0. We can put any value here. It does not matter where this object gets created in the room because it's going to work either way. So you could put 100, 100 or whatever. I just put 0, 0, which is still a location. And then it can be any of the layers, but one layer that I know is going to exist in every single room is the player layer. So I'm going to do that. And then fade is the object. And since everything in fade is already set to default as fading in, there's nothing else we have to do in this script. For fading out, we have to adjust some things, but for fading in, this is all we need. So let's go somewhere where we can test the fade in effect. Let's go to our room code. Now remember, the room code script runs in the creation code of every level we're going to be creating. So we already know that this will happen at the beginning of our level 1. Add fade in. And now let's run the game. See if I added any bugs. Oh, there's a fade in. A purple fade in, which, you know, I kind of like. I don't know, maybe black is better. Kind of want it to be like a dark purple. It's kind of a bright purple. Either way, let's maybe change that back to black. I reserve the right to change it to a dark color. Is there any other colors we can do here? Let's see. GameMaker manual. We can create our own color. Purple. Purple is that. We can create our own color, but that looks good the way it is. Let's change this back to black. Yeah, it looks better with black. If I created a custom color that exactly matched our background color, I think it would look even just slightly better, but that works. So we have our fade in when the room gets started. Now, to fade out, we need to alter the instructions in the fade object, and we're going to do it in our fade out script. So scripts can take information from you, and we call this information parameters or arguments, which are like inputs in the script. And those parameters or arguments are stored as local variables in the script. So with the script like fade in, we don't have any arguments. It's just run the script. But with fade out, we're going to have some special instructions. So let's create a new script called fade out. So the part of writing, a good part of writing a script with arguments or parameters is that it's good to take notes of what those are up here. And you do it with a couple of special words and slashes. So I'm going to just delete all that and I'm going to write triple backslash at function indent fade out, open parentheses, target room, close parentheses, triple slash at param, meaning a parameter, open curly bracket, index, close curly bracket, indent, might indent this, indent that again. And I'm going to call this target room with an underscore because I'm going to remind myself that this is a temporary variable and that's my naming convention for temporary or local variables. And now where it says function and then the name of the function, in these parentheses, we can write the name of our local variable or temporary variable underscore target room. So that when we call the script fade out, we put in some information like our level 1. We give that function or we give that function some information. And then that information is stored as a temporary variable and we can use that information in the script. So let's write out the rest of our script. If bang instance exists, fade. So if this object doesn't exist, double close parentheses, var underscore fade equals. Now this is kind of funky. We are going to use a function here, instance create layer, and whatever object we create with this function, it's going to create a custom ID number and assign that number to this here so we can refer to that specific instance later on. It's kind of a cool feature in GameMaker. Just create it 0 or 0. It doesn't matter where you create it. Player layer, fade. So now we can adjust things in this specific instance of fade with a with statement, with underscore fade. So whatever code we run in here, it'll run it as if fade is running this code. We're going to say a equals 0. So instead of being 1, we want it to start as completely transparent first. Fade out equals true because we want it to fade out and run the fade out code. And also target room equals underscore target room. So it'll take whatever target room we give the function and it'll give the fade object that room to transition to. And that's it. We can use the script to see if it works. And a good place to test to see if it works is in the death script. So in the death script, delete everything here. Just delete it all and just write fade out and then global.checkpoint room. Checkpoint underscore room. So that when we touch an enemy or a hazard, it will do the fade out script and the room that it will transition us to is whatever is stored as the checkpoint room. Let's run the game, see if it works. Okay, so we start here. I'm going to touch this checkpoint and touch this hazard. There's a fade out, you see? Fade out. It takes us back to this room. So it is working. So you'll notice in the game that we can still control the player after we touch a hazard. Like I can still move it a little bit, which we don't want to have happen. Instead, let's cause the player to explode just like our enemies do. So in our death script, before we call for the fade out, we can write instance create layer x, y, in the player layer, and the object we want to create is explode. And then after our fade out, we'll write instance destroy, which is destroy our player object, because the only object that calls the script is the player object. so that now that when we touch a hazard, our player object should explode. And it does. And it should do that same thing when I touch an enemy. Beautiful. All right, so let's make it so the player can't move during fade-ins and fade-outs, because right now when the room starts, hold on, I can still move when it fades in, and we want it to not move when we fade out, like for when we're moving between rooms. So let's alter some of our code in OPlayer in the inputs section. We're going to add a condition right after we get all the inputs. So right here, it gets all the inputs of the keys that the player is pressing. Then afterwards, we're going to set it if instance exists fade. So if there's a fade in or fade out, take all of these values and just change them to 0, which is very easy to do. I'm just going to copy, I'm going to paste, and now I need to, they're already declared, so I need to get rid of var here. So delete var, delete var, delete var, delete var, and then set all of them to 0. So 0, semicolon. Highlight that, copy, and paste over here. And this simply checks if there is a fade object, indent that. And if it does, it changes whatever values it's storing from the key presses and just changes them to 0. And because this code runs after here, whatever values, if I'm holding left, this is 1, and then it goes here and says, hey, does fade exist? If so, just change it back to 0. So I should be able to see it doesn't let me move until the fade out is the fade in is over. So let's start moving between different rooms using our fade in and fade out scripts. So we first need to make an object that's going to be a door object that if our player touches it, it transitions us to a different room. So let's start that by creating a sprite. Call this S door. I'm going to set it to be 64 pixels wide, but 128 pixels tall. It works with the design of our game. I'm going to keep its origin at top left. FPS is obviously 0, and then I'm going to edit the image and just give it a bright color. So I'm going to give it a color of maybe a bright green. And if you want to get really fancy, you can even like select the pencil and write door. Because we're actually not going to see this in the game. It's going to be not visible. So now create an object, door, set the sprite that we just created. And here where it says visible and it's all automatically checked, just uncheck that so that we'll be able to see it in the room editor, but when the game runs, we won't be able to see it anymore. Now add a create event. Let's declare some variables. Target underscore X equals 0, target underscore Y equals 0, and target underscore room equals, just as a default, whatever room we're in. Temp room will be changed. In fact, all these values will be changed. Because what we want to have happen is the player will touch the door, and then whatever we set these values to be, it'll take us to this whatever room we set and whatever X and Y location we set in that new room. In the step event, write if place meeting X, Y, O player, double close parentheses, fade out to, and we're going to actually input 3 parameters here, and we need to go back and edit our fade out script. So the 3 parameters are those 3 things we added in the create event, which are target underscore room, comma, target underscore X, comma, target underscore Y. So we need to change this script to allow for these other parameters. So exit out of that, go to fade out, and let's add those other things here. So triple backslash at param, indent, curly bracket, call this integer, and curly bracket, indent, underscore target underscore X, indent target X location for player object. So you can also add comments here. Target room, And then I'm just going to copy this, paste it, change this to target Y location for the player object. And you're going to see how this is helpful in a moment. I'm actually going to show you why we take these notes in this particular format in one moment. So here, let's add these other local variables, comma, underscore target underscore X, comma, underscore target underscore Y. And now up here, let's set global.target underscore X. This is a new global variable that we will declare in a moment, equals underscore target underscore X. Global.target underscore Y equals underscore target underscore Y. And this all stays the same. Now, the reason we're adding new targets or new global variables is that we want to be able to move between rooms without using a checkpoint. But we still need access to these global variables. We need access to these variables, which is why they're going to be global. Let me just make sure there's nothing else we need here. I think that is it. Okay, next we need to declare these new global variables. We're just going to do that by going to r/ creation code global.target underscore X. And what I like to do is when I'm declaring these, I just set them to be whatever these are. So 416 global.target underscore Y equals 480. And these will be changed as needed. And let's close out of that. Now we'll go to the room code here where it creates our player. Now we're going to change it from being checkpoints to those new target X and target Y, because we want to be able to move between rooms without it triggering a checkpoint or relying on checkpoints. Now we could do it. We could do that when you move to a new room, it automatically creates a new checkpoint wherever you get moved to in the new room, but I'd rather not. I like the flexibility. So we're going to run the game just to check for bugs, but nothing should have changed. Okay, so it's just everything's working same. It didn't give me an error message. Okay, so now we can implement our door system. How we're going to do that is I'm going to right-click on our level 1 and right-click our level 1 and go to duplicate. You can also highlight it and hit Control or Command D and call this R level 2. Duplicating is just a fast way to get new rooms because the creation code stays the same and it has like all the exact same layers, which is helpful. And so what I'm going to do is I'm going to get rid of all of our enemies by highlighting that, and I'm going to get rid of our checkpoints for now. And in fact, I'm going to get rid of these extra blocks so that we know that things look different. And I am going to build out a place for our door object. So I'm going to put it right here. The player layer, door. So it's right off screen. But, you know, the player will touch it. So that makes sense there. And I am going to add a checkpoint like right here. And I'm going to add one hazard over here so we can do a test later. Okay, that looks good. And then our level 1, I'm going to hit the player layer. And similarly, add a door right here. All right, so not only do objects have a creation code and rooms have creation code, individual instances of objects has a place where you can add creation code also. That's unique to each instance, just, well, I was about to say just like the sign system, but we haven't built the sign system yet, so don't worry about that. Anyway, here on this door, I can double click this and allows me to change the creation code of this specific instance. And so what I'm going to do here is I'm going to open our level 2 here. And I'm going to find a location where we want the player to appear in this new room. I'm going to do that by just like dragging in the player, finding a good location, double clicking here and finding its coordinates 32, 480. Delete. Target X equals 32. Target Y equals 480. Target room equals R level 2. So with this instance creation code, it changes those default values that we have in the object and gives them more precise values of where we want it to go. Similarly, here in our level 1, we need, where's the player object? There we go, player. Find a location here in our level 1 that we would want to come back to, 864, 480. Eight, 6, 4. 480. Target room equals R level 1. So I think that's right. I'm in R level 2 and I want to go back to R level 1. That's correct. And then from R level 1, we'd want to go to R level 2. Very good. Yeah, so before we run the game to see if it all works, and there might be a bug, I want to explain everything that should happen, just so you understand all the code that we just added. So first, the player is going to walk, the player object is going to come over here, and the player object is going to touch or overlap with this invisible door object. It's invisible because we set it to be not visible in the object options right here. Once it does so, this specific instance of the door object will have a specific target locations for the X and Y and for the room in its instance creation code. And that door object's step event will take that information and input it into our fade out script. Now, this is what I was telling you. You click fade out script, and down here, it gives us that information that we put into the script, target room, target X, target Y. So if you ever forget what parameters you need to add to a function, they appear right down here. That's why we added those comments. And then that script will run. Where's the script? Fade out. And what that script will do is that'll take those target X, target Y, and target room parameters, and it'll set global.targetX to be where we need to go, target Y where we need to go. It'll create an instance of our fade object, and it'll take us to our target room. And then once our target room opens, it'll use global.targetX and global.targetY and plant our player there. But I see an error, so I just want to make sure I get this error taken care of before we run the game. I highlight this, type undefined appears where the type real is expected. I don't think we have an issue. I've declared these. Huh. Let me just make sure I have them declared properly. Target X, target Y. Well, let's run the game, find out if I have a bug or not. Okay, so our game opened. That's a good sign. So I'm going to hit this checkpoint right here. And we move between rooms. And now I've touched this checkpoint. This is the active checkpoint right here. So if I touch the hazard here, oh, there we go. I knew there was an issue. Incorrect. Expecting a number. Global target X, global target Y. Room code line 8. Instance create layer. Has to be in here, so let's check it out. Okay, I might cut the video here and jump to when I found the solution if this goes on too long. So if I don't find it really quick, expect a cut to come where I jump ahead to the solution. All right, I found the solution. It was very simple. In our death script here, so if I double click on death, I needed to update here where we use the function of fade out to include all of our parameters. We added 2 parameters, so we needed to add those, hence the problem. So hopefully I edited that out of the video. Anyway, so that is working. Now that we have fading in and fading out, let's add a camera system. So first, our level 2, just delete it entirely. We don't need it for now, so delete it. And we're going to make some changes to our level 1. We're first going to make it much bigger. So go over to width, and I say 1600 by 1280 should be good for us. And everything in my game is set to like a 64 by 64 pixel square. So I try to choose coordinates that play nicely with that value. And 1600 and 1280 are divisible by 64. And I am going to just go ahead and delete all these blocks. I'm going to delete something happened there. No worries. I'm going to go to bad, delete all those things there and the checkpoints. And I am going to do some new level design. First, let's create a new layer and call it blocks. Because we want all of our blocks to be on one layer. I'm putting it underneath everything. Blocks. Under player, I'm going to delete the rest of these. So whenever we place blocks now, it'll be on its own layer. So it'll be very easy to isolate, remove, and add. So I'm going to highlight blocks. And the first thing I do is I first set the grid to be 64 by 64. And I make sure we can never leave the room. Oop. Let's delete that. And then after that, let's just build a simple level. Let's block. Let's have it here, and let's have some hazards here. Let's have a wall jump here. And let's add some enemies here. Actually, I'm going to start a little higher. I shouldn't be wasting your time with this. But it's fun. What can I say? It's fun. Sort of, yeah, there we go. Right there. Yeah, that's good. Let's do this. Let's have our enemies right here. And then that'll be the door out. There you go. Actually, make it a little higher. Let's add some baddies. Let's add some hazards. Let's add some checkpoints. Add a checkpoint here. And I think it's beginning to look good. Let's find a new starting place for our player. Let's start the player like right here maybe? All right, where are you at? 256, 1120. 256, 1120. 256, 1120. All right, 256, 1120. 256, 1120. And immediately delete that player object so it actually gets created. And now we need to create a camera system. And first we need to adjust some settings here in our level 1. So click our level 1, and then you'll see down here underneath the creation code and where you set the width and height, this window for windows and cameras, viewports and cameras. We're going to open that up and check enable viewports. Open up viewport 0 and check visible. And then we're going to make the width and height of our default game screen, which is 896 by 576. And then do the same thing over here to viewport properties, 896, 576. And we're not going to set it to follow any object because we're going to handle all of this in our code. So now we have a camera object. Yes, very good. Now create a new object called OCamera. And in the OCamera, create event, we're going to define a lot of parameters. Cam equals view camera square bracket 0 close square bracket semicolon. Give a name to the room's camera. So we can always just use view camera 0 as the name, but it's just nicer to write cam in our code so we know what we're talking about. Cam underscore follow speed equals 16. Lower is faster because we want the camera to sort of have a follow speed so it's not locked exactly onto the player object. As the player moves, the camera sort of trails a little bit and it'll catch up. Follow equals O player, meaning this is going to be what object to follow. And the reason why we create a variable for this is that we can change that variable to be like, what if we want the camera to go look at a sign or an enemy or have a little cutscene? We can change what the follow object is, but by default, it should just be the player. Width underscore half equals camera get view width of cam times 0.5 or divided by 2, whichever you want to do, used to find the center of the camera. And height underscore half equals camera get view width cam times 0.5, same thing. X2 equals X. X2 is where the camera wants to go. Y2 equals, X2 equals, X. Y2 equals Y. Y2 is where the camera wants to go. And then in the step event, comment update destination. If instance exists, follow. If our follow object exists, double close parentheses. X2 equals follow.x. Y2 equals follow.y. I'll add a comment. Sets X2 and Y2 to that object's X and Y position. New comment, update object position. X plus equals, there's some fancy math here, X2 minus X in parentheses divided by cam underscore follow speed, semicolon. Comment moves slower the closer it gets to the follow object. Y plus equals Y2 minus Y in parentheses divided by cam follow speed. Same thing. Comment keeps the camera from leaving the room boundaries, because when our player object gets right against the wall, we don't want our camera to show what's outside of the room. We want to keep it within the room. We write X equals clamp, X width underscore half, width underscore half, comma, room width minus width underscore half. Y equals clamp, Y, height underscore half, comma, room height minus height half. Height half, width half, yes. So it's clamping the X position within the values of width half, room width minus width half. Yep, that works right. Just checking. Update camera view. And it's written this way, by the way, because the coordinates of the camera we're setting it up so the actual in-room camera's location is defined by its top left corner, but we're doing all of this math because we want to move the camera object in the middle of what the room camera sees. So as the camera object is in the middle, and then you have the square of the camera that moves around it. So that's why we have some funny math there. And then lastly, camera set view position or POS. Open parentheses, cam is the camera we want to change its position, x minus width underscore half, comma, y minus height underscore half. Whew. So we have our camera, but we need to add the camera to our room. So it's very easy. Go to our room code, and underneath where we create our player object, we do the same thing here. I'm just going to copy this and paste it in. Instead of O player, it's going to be O camera. O camera. And this has the added benefit of automatically putting the camera right where we need it to be, at the same location as the player in the room. Whew, so let's test it out. Oh. We have an issue. It's not following. All right, I found the problem. Here where it says height half, camera get view width, I needed to write height there. That is the issue. So if I run the game, it should work properly. There we go. It works properly, and we have this following us properly. Beautiful. All right, so let's move on. We have a camera that's working, but let's add a screen shake effect in our game for our camera object. So we just need to add some code here and then write a script to call a screen shake whenever we want it. In our camera object, in the create event, let's add a section called screen shake with a comment, shake underscore length equals 0, which is time length in frames for how long we want the screen shake to go on. Shake magnitude equals 0, which is how big of shakes in pixels. Shake remain equals 0. Countdown timer for screen shake. Buff equals 32, which is half of this sort of tile system I have in my head for the game, which is 64. So buff of 32 means distance in pixels from the edge of the room. And in the OCamera step event, we want to update the clamps to include this buff or buffer variable, which is really easy to do. We just add width half plus buff, height half plus buff. Over here, width half minus buff, height half minus buff. And we're going to add some more code right before we update the camera view. It will be called screen shake x plus equals random range, open parentheses, minus shake underscore remain, comma, shake underscore remain, which gives us a random integer between like negative, let's see, if we set shake remain to be like 10, it'll give us a random value between negative 10 and positive 10. And then y plus equals random range minus shake remain, same thing. And then make magnitude of shake get less intense over time. And here we're going to do some fancy math. Shake remain equals max 0, whatever is bigger, shake remain minus open parentheses, 1 divided by shake length, close parentheses, times shake magnitude, close parentheses, semicolon. So this will make the shake be the biggest right at the beginning of the shake and then reduce it in its intensity over time. Let's create a new script called screen shake. Create script, screen shake, and right up here, triple backslash at desk, indent, screen shake, open parentheses, magnitude, comma, frames, close parentheses, triple backslash at param, indent, open curly bracket, magnitude, close curly bracket, magnitude sets the strength of the shake, radius in pixels, triple backslash at param, indent, open curly bracket, frames, close curly bracket, indent, frames, sets the length of shake in frames, 60 equals 1 second at 60 FPS. And here is our function. Name some of these variables, underscore magnitude, comma, underscore frames, with camera. So it'll run the code in the camera object. If magnitude, underscore magnitude, is greater than shake remain, open curly bracket, close curly bracket, shake magnitude equals underscore magnitude, shake remain equals magnitude, underscore magnitude, and then shake length equals underscore frames. See, this gets recognized. There we go. And to test it, let's add a screen shake to the death script. Very simple to do. Let's do it right up top. Let's add screen shake, open parentheses. So here it tells us what we need to add, a magnitude and length in frames. So magnitude we'll set to 12 pixels, length in frames 30 frames or half a second, semicolon. So if I didn't add a bug, when I touch the spikes here, we'll see a little camera shake. Little screen shake, see? Beautiful. Now we can use this wherever we want. So let's add it to checkpoints. When we touch a checkpoint, to just add some visual oomph. So right after we update all these values, let's say screen shake 510. So it is magnitude of 5 pixels and it lasts for 10 frames. And then for player, where we attack, where it creates the weapon, screen shake. There we go. Let's say 4 pixels for 10 frames. And let's test it out. So when I use the weapon, now I get a little mini screen shake. Just barely, just something for a little bit of visual emphasis. And when I touch a checkpoint, we get a really miniature screen shake as well. All right, so we can use that script whenever we want some visual emphasis to anything. So that is it for our camera object, and I'm feeling pretty good about where the project is thus far. We've got a camera object, we have bigger rooms, we have some basic level design, we have a screen shake effect, we have transitions between rooms that we can do whenever we want. And just a quick note, be sure to design your rooms appropriately so you don't end up having too small of a side of a buffer. So right now I'm only seeing 32 pixels of this sidewall. If I want more of that, I just got to design my rooms to have an extra tile worth of blocks over to the side, which is doable. I might do that. And in the next video, we're going to add some polish with some sounds, some auto tiling, so something to graphically replace these blocks so it actually looks like it fits in the game, and some tutorial signs to teach the player how to play the game. And good luck, and I will see you in the next video.